Welcome to this video on superposition. In this circuit, we will analyze for the voltage across R2, R, VR2. The circuit has two sources, V1, which is 10 volts voltage source, and I1 is a 3 milliamp current source. So to use superposition, we need to eliminate one of the sources. We will eliminate I1 first by opening it up. Once that is done, then that leaves R1 and R2 in series. We can find the voltage drop across R2 by using the voltage division rule. So step number one, the voltage due to V1 will be VR2 is equal to, that's due to V1, is equal to R2 divided by R1 plus R2 times V1. Substituting in our known values, that comes out to be 2k ohms divided by 1k ohm plus 2k ohms times 10 volts. Substituting that into our calculator gives us a result of 6.67 volts. And it's in a polarity of pluses on the top and minuses on the bottom. Alright, now the next step will be to solve the circuit using I1 as a source and by shorting out V1. Once that's done, you can see that R1 and R2 now are in parallel. So to find the current in R2, we can use the current division rule and solve the circuit here based on I1. We have IR2 is equal to, that's due to I1, is equal to R1 divided by R1 plus R2 times I1, which is equal to 1k ohm divided by 1k ohm plus 2k ohms times 3 milliamps. That yields a current of 1 milliamp. Once we know the current in R2, then we can find the voltage across it, which will be VR2, and that's due to I1, is equal to IR2 due to V1 times R2. Substituting, we have 1 milliamp times 2k ohms which yields 2 volts. Plus is on top, minus is on bottom. Now, our next step is to solve for the total net voltage here. So VR2 total is equal to VR2 due to V1 plus VR2 due to I1, and they're added since they're both in the same direction. Substituting, this is 6.67 volts plus 2 volts, which gives us 8.67 volts for the voltage across R2 due to both the voltage source and the current source. That concludes the video on superposition.